Hello everyone, this is Ari from pantechelearning. So in previous session, we saw how the SPI communication works and how the transmission works, and we have shown what are the registers in the SPI communication. Okay, so in today's session, we are going to develop the code for SPI communication. Okay, so before that, we have to see what are the steps we have to do, right? So we will get into it. So first is we have to configure the system clock configuration as per the same thing. So we will generate the system clock as 64 megahertz and the P clock as 16 megahertz. Okay. Then we have to create the GPIO alternative function. We have to set 4 pins because SPI is working in the 4 pins. So we have to use the 4. We have to set 4 pins alternate function. Okay. Then we have to create a function for initializing the SPI. Then we have to create the function for SPI enable, disable, and we have to transfer the files like so SPI SPI transfer function and save SS means it is save select pin, or you can say it as it will be mentioned as a CS. CS means it will be chip select. Both are same. So we have to create the function for save select enable and disable. Okay. So we will see detailedly what we are going to do. Okay. So in initialization, we have to first enable the clock for the SPI. So then we have to select the polarity and phase. What is clock polarity and what is clock phase? Now I will teach you. Okay. So you can see it here. So we have a clock polarity and clock phase. So this clock polarity is going to say from where to stop. Okay. Then the clock phase is going to say to where to capture the data from the first clock transition or second clock transition. So we have to configure this as per the slave specification, or if you are making a communication between two STM controllers means you have to set the same polarity in the slave side also. Okay, and phase also you have to set the same phase. So this is a I will show you detail. Wait. So guys, you can see here when it is polarity, if you give us polarity as 0 means it will start from the polarity will say from which state it has to stop. I have to start the data transmission from the high value, or I'm going to start it from low. So that is what polarity is going to say. Right, I will zoom it. So guys, is it visible? So guys, so polarity will say the line starting stage. It is in an initial stage of the line. It is a low or high. So if I give a polarity as 0 means it will be starts from low. If I give a polarity as 1 means it will start from high. Then what is phase means? The phase will say the from which place I have to start the data capturing. So you can see if I give phase 1 means it will takes my first rising edge, from that place only it will capture the data. When I give phase 0 means it will capture the first rising or lowing thing. So it will capture the data from those positions. So by giving polarity 0 means it will by giving polarity 0 phase 0 means it will capture the data on first rising edge. If I give polarity 1 and phase 0 means it will capture the data in the first lowering frequency. Okay, as same as here. So if I give 0 means it will take in the second lowering time, and if I give polarity 1 means it will take at the first rising edge. Okay, So this is what clock polarity and clock phase. Okay, guys. Okay. Now you will get into. Then what we have to do? Then we have to configure what is the thing we are going to do with the controller? We have to say we are going to use it as a master or slave. So we have to configure slave or master, and we have to set the baud rate for SPA. Okay, I will show you in how to set the baud rate, and we have to say which bit we are going to give first. We are going to send the MSB first or LSB first. It is as per our choice or as per the slave's characteristics. Okay, and here comes the software and hardware management. What is this? So SPI communicates with uses four pins, right? So one pin is for slave circuit. So there will be a default slave circuit. So if consider I am going to connect it, I will show it yesterday. Right. So consider I want to select I want to connect three slaves in three different pins. But what is the problem? The SPI will have only one slave circuit. So now I want to use the other pins for selecting the pins. So in that scenario, I will give the software. I will go with the software management. By using those software management, I can add the GPIO pins as a slave select pins. I can change the GPIO pins as a slave select pins. Okay, so that is the use of the software management. If it is hardware management means it will be only one slave select pin which is given by default. Okay. Then we can say it is full duplex or off duplex. Okay, we will configure in full duplex. Okay, then we will say the bit format. We are transferring 8-bit format or 16-bit format. We have option as 8 and 16. Okay, so next we have to enable the GPIO clock. Then we have to set alternate function mode register, and we have to set the alternate function for four pins. So this is the function we have to create for GPIO. Then comes to the SPI transfer. First, we have to wait for TXE bit like UART. Then we have to load the data to the register. Then we have to check whether the TXE again we have to check with TXE bit, and we have to check whether the SPI is busy or not. Then finally, after it is exiting this loop, we have to read the status register, data register to clear these bits. Okay. Then we will create these other functions also: SPI enable, disable, and slave select enable, disable. Okay. So these are the functions we are going to create, guys. Okay. So now we will get into the KEIL. Project. First, we have to select the board, right? Right. So select the census code and starter file. Okay, add the starter file. Okay, now we have created the project. Then we have to add the .c file. So what is the first thing we have to do? We have to do is we have to include the starter file. Okay, so now we have included. So as in previous slide itself, in previous classes itself, we have created the system clock configuration. It will take time. I will just make a copy of it. So we are going to use the system frequency in same frequency we have created, which is 64 megahertz, and the B clock is 16 megahertz. Okay. So now we have created the system clock configuration. Now what next we have to do? We have to go with the So now we are going to create this init function for SPA. Okay. So first thing we have to enable the clock for SPA. Okay. Where is the clock will be? It will be the SPA1 is connected to the ABB to bus. So we have to go for RCC. Go to the RCC. APB to ENR. So you can see we have SPI1 in the 12th bit. So we have to send logic 1 here. Okay. So we will send the logic 1 here. So this will enable my clock. Okay. Then we have to give the polarity and phase, right? So go to the SPI control register, and we have a 0th and first bit as a clock phase and polarity. So I am going to use this. I am going to use the polarity 0 and clock phase also 0. I am going to capture the data in the first clock transition itself. Okay. So I'm going to set logic 0 to these bits. So SPI. So this will set my phase and polarity as 0. Okay. So next thing we have to do is we have to select this as a master, because we are going to connect the, we are going to make this controller as a master. Okay. So go to the same control register. You can see the second bit as a master or slave configuration. So I will simply send the logic on to the second bit, then it will be as a master configuration. So SPI of control register and left shift off. In which bit it is having? It is in the second bit. So now we have configured as a master. Then now we have to go the frequency, right? So go to the register. So you can see here baud rate. So this is a baud rate control. So what is the frequency we are getting? We are getting a 16 megahertz, right? Peak clock is 16 megahertz. So I am going to divide it by 4. So my baud rate is 4 megahertz. So it is going to work in my 4 megahertz of frequency. So for that I am going to simply left shift the logic 1 to the third bit. Okay. So SPI off. I will make a zoom. Okay. And left shift of 3. So this will set my baud rate as 4 megahertz. Okay. So next we have to select whether we are going to send first MSB most significant bit or least significant bit. So first I am going to send a most significant bit. So we will send a logic 0 there. To the which bit we have to send? We have to send to the 7th bit because it is located on the 7th bit. Okay. So we have set the most significant bit as a first. Okay. Next we have to select the software slave management. So we are going to use the other bits. So that's why we are using this. So next we will go to the. So you can see we have a software slave management. If you enable this means this SSI also will be enabled. So you have to send logic 1 to these both the bits. Okay. So go to the SPI now. Now start on left shift off 8 on left shift off 9. Okay. Now we have selected the software slave management. Then we have to configure it is full duplex, right? So go to the same register. You can see we have a receive only mode and full duplex mode. So we can receive and transmit. So we will select this as a full duplex mode. left shift off. So it is in the 10th bit, right? So now we have set as a full duplex mode. Now we have to set the bit format. What is how much bit you are going to set? So you can go to we have a data frame format. So I'm going to set logic 0 here to and because I'm going to use the 8-bit format. Okay. So SPI off. Okay. Then we will make the control register 2 as a 0 because we are not going to use any peripherals in the control register 2. So SPI of SPI 1 CR of 2. Then we will create a function for GPIO. Okay. So what are the things we have to do? First we have to enable the clock. So before that we have to know which pin does the clock is having, right? So go to the, you have to check the pin diagram. So you can see we have an SPI 1 in the port B of 3, 4 and 5 and 7. Okay. So we are going to use the software slave management. So this 7 is not needed. We will use other pins. Okay. So we will use the 6th pin as a slave 7 pin. So we have to configure the port B. We have to enable the clock for the port B and we are going to configure those pins. Okay. So RCC of, it is in a AHB 1 ENR. Okay. AHB 1 ENR bus. One left shift of 1. So it will enables my port, enable the clock for my port B. Then we have to select the mode. So what are the pins we are going to use? We are going to use this 3, 4, 5 and 6. Okay. So I have to configure this 6th pin as an general purpose output mode. Then these 3 pins as an alternate function because MOSI, MAS4 and clock. And this is the slave select pin. Okay, that's why I'm configuring this slave select pin as a general purpose output mode and other left 3 pins as an alternate function. Okay, so simply I will send the left shift the 2 to this 6, 8, 10th bit and I will send the logic 1 to the 12th bit. Okay. Okay, now we will send the, so it is in the GPIO of B. Okay, so GPIO of B in mode R. In mode R, I'm going to left shift it by 6, left shift of 8, 2 left shift of 10. So this will set the alternate function for 2, 3, 4, sorry 3, 4, 5 and 6th pin as a general purpose output mode. So I will simply send the logic on to the 12th bit. So this will set my 6th pin as an output mode. Then we have to give the set the alternate function, right? So we are using this first with first 0 to 7 pins. So it is in the low register. Okay. So GP. It is in the low register. So we will find the what is the function we have to do. So go to the functional description. So you can see here we have SPI in AF5. Okay. So go to the low register. AF5 is value is 1 plus 4, 5. So we have to left shift the 5 to the 12th position, 16th position, 20th position. So this will set my alternate function. Okay. So 5 left shift of 12, 5 left shift of 60, 5 left shift of 20. Okay. So now we have created the GPIO function. Okay. Then we will create a function for SPI enable. Okay. So void of EL. So we will create it. So go to the control register of SPI. In that you can see we have a 6th bit as a peripheral enable. So we have to send logic 1 to the 6th bit for enabling the SPI. So we will SPI of 1. C of 1 left shift of 6th bit. Okay. So this will enable my SPI. Then we will create a void of SPI disable. Okay. So now we have to disable the SPI. So we will simply send logic 0 to the 6th bit. Then what we have to do? Then we have to create a function for SS, right? So SS enable. So to enable SS slave select pin, we have to, it is a general output mode. So we have to send logic 1 in the, wait, we can go to the registers. You can see, so we are connecting the 6th pin as a slave select pin. So we have to send logic 1 here, and tune of this, we have to send logic to the 22nd pin. So when you enter the SPI communication, the first how the slave will understand it is in a, it is going to communicate. So what it's going to do is the pin SS pin will be in the high state. So from when the pin is toggled between high to low, then the slave will understand it is going to come send or request the data. So what we have to do means do GPIO of B. Okay. So GPIO of BSR. So BSR of, so 1 left shift of 6. So it will make my pin in the high state. Then I have to make it low, right? So to make a communication. So this is how the pin is, the slave is selected. Then we have to disable, right? For disabling, again we have to set the pin in high state. So for void of, so this will, okay, this will disable the slave select. Then what is the final function we have to create? We have to create the final function as for SPI transformation. Okay. So we will create as a void of SPI of trans. So now we will get into it. First we have to initialize the I is equal to 0. Okay. Then we have to create a while of, because we have to send the data as per the size. So we are going to do a size. The while is going to run till the size is exceeding this loop. Okay. So we have to check whether the TXT bit is set or not. So the TXT bit is in status register. Go to the SPI status register. We have a busy flag here in 7th bit and transfer buffer empty in first bit. Okay. So we have to configure both the bits. Okay. So SPI under shift of 1. So I have to wait till this bit is get set. Okay. Then now I have to send the data to my data register. So as per the I, it will sends the data, loads the data to the data register continuously. Okay. Then we have to increment the I. Then we have to wait till the TXT bit to set. So the same thing. Okay, then we have to check whether the SPI communication is busy or not. So we have to wait till the it is get a reset. Okay, we have to wait till the reset state. So SPI it is in the 7th bit. Then we have to read the value to clear these two bits. Okay, so we have to read the status register and data register. So I will create a temporary variable. Okay, so SPI of 1 SR. Now this will clear these bits. So now we will compile it. Okay. So we have error. Why? Because we have to create a main function, right? So now we will get into the main function. So in main function we have to first we have to add the system block. Then we will declare data which I have to send unsigned of. I will make it the size as 2. Then initialize the GPIO. Then initialize the SP. Okay. So GPIO. Now create a while loop. While off, now we have to enable the SPI. Okay, already we have created a function for enabling the SPI. So enable the SPI by calling those functions. Then enable the save select pin. Then now we will transfer the data. What is the data we need to transfer? Okay, so SPI of trans of my data. and we have to mention the size. Okay, what is the size 2? So then we have to disable the SS, then SPI. Okay, we will compare it. So you can see we have no errors. These warnings are, we have to mention these all things. So you will make it a, wait a second. So this is how we will develop the code for SP. Okay. So guys, if you have any doubts related to this code means you can we will have it in a Saturday one-to-one class. Okay guys, so we will make an interaction there. So the doubts related to the codings and if you have some errors or if you have some struggles while developing code means you can ask me directly in this internship class. So it will be every Saturday we will have a one-to-one live session. So you can have a good introduction and you can gain knowledge and make use of it, guys. So you can now convert this masterclass into an internship, the 1 month internship on embedded systems. So when it comes to the YouTube content, it is going to be different than in internship. It is going to be adopted and expanded. And guys, the fees is 1200 and discount is 509 and the coupon code is ESMC1. So use this coupon code to get this discount and the final price is 691, guys. So the batch 2 is started. So use this to register, make the registration and make use of it, guys. So what are the benefits you are going to get? So you will have a 30 days of live session recordings and you will have a 90 days access for it. And you can try all those things which I have been teacher, and you can get an hands-on practice on the embedded projects, and we will develop the lots of interfacing sensors and lots of things in the internship. And you can have a 30 days of downloadable presentations. And the main advantage here is we will have a one-to-one mentor live sessions for 6 days. Okay, from Sunday. So already one live session is over, guys. Make to register today so you can attend this Saturday's live session. Okay. And after registering, you will get an information confirmation letter, sorry, internship confirmation letter, and the e-certificate. So we will provide two e-certificates. One is for participation, and another one is for close completion. Okay. Okay. So how to register? So guys, the fees is 1200. The coupon is ESMC1. So use this to get this discount, and the final price is 691. So this link will be provided in the chat box, guys. So use this link to register for the internship. Okay, don't miss this opportunity, guys. Okay. Okay, guys. I think today class is clear. So we will meet on next session. Thank you, guys.